In this video, I'm going to solve this question. If the regression model yi equal to beta1 plus beta2 x2i plus beta3 x3i plus ui is estimated using the method of least squares, prove that the OLS residuals, that is ei, would be uncorrelated with the estimated y values. So, we are given a population model in the question, and the population model that we are given is yi equal to beta1 plus beta2 x2i plus beta3 x3i plus ui. The sample counterpart of this model can be written as follows. So if we write the sample counterpart, it will be yi equal to b1 plus b2 x2i plus b3 x3i plus ei. So b1 is the estimator of beta1, b2 is the estimator of beta2, b3 is the estimator of beta3, and ei is the sample error, that is residuals. We know that this term that we have over here is yi hat. So this is what your estimated y values equal to. So the equation of the estimated regression line is yi hat equal to b1 plus b2 x2i plus b3 x3i. So this is the equation of your estimated regression line, and this is what yi hat is equal to. Okay, now we have to prove that the correlation between the residuals, that is the correlation between ei and the estimated y values, that is yi hat, is equal to 0. Or in other words, we can also focus on proving that the covariance between ei and yi hat is equal to 0. Because if the covariance between two random variables is equal to 0, even the correlation between those two random variables is going to be 0. So what I'm going to do is I'm going to focus on this part, as this is going to be simpler. And if we are able to prove that this covariance is 0, then it will automatically imply that even the correlation is 0. Okay, so let's get started with the proof. Let's see how can we write covariance between ei and yi hat. We already know that yi hat is equal to this. So that means I can write that this expression is equal to covariance between ei, and instead of y hat I can just write this expression over here. So it's b1 plus b2 x2i plus b3 x3i. Now we can use the properties of covariance to evaluate this expression. Basically this expression can be written as covariance of ei with b1 plus the covariance of ei with b2 x2i plus the covariance of ei with b3 x3i. So this is one of the properties of covariance, and we can utilize this property over here. So this implies that we can write covariance between ei and yi hat as covariance between ei and b1 plus the covariance between ei and b2 x2i plus the covariance between ei and b3 x3i. Now let's evaluate this further. So this implies that covariance between ei and yi hat is equal to, the first term over here is the covariance between residuals and b1. Now note that b1 is going to be a constant over here. Reason being, you are given this particular model, and if you estimate this model using the method of least squares, you are only going to get one value of b1, right? So b1 is a constant. On the other hand, ei is a variable because it can take multiple values. If you have a sample size of 100, then ei can also take 100 values. And from your basics of statistics, you should know that the covariance between a variable and a constant is going to be 0. So this is 0. Plus, let's take a look at the second term now. In the second term, we have covariance of ei with b2 x2i. Now once again we can apply a property of covariance to solve this. ei over here is a variable, b2 is a constant, and x2i is also a variable. Now according to our property of covariance, we can take the constant out and we can write this expression as b2 multiplied with covariance of ei with x2i. Similarly, in the third expression, EI is a variable, B3 is a constant, and x3i is also a variable. So we can take the constant out, that is, we can write B3 covariance of EI with x3i. So the final expression that we get for covariance of EI with yi hat is equal to B2 times covariance of EI x2i plus B3 times covariance of EI with x3i. Now to evaluate this further, we need to figure out what is this covariance of EI and x2i and what is this covariance of EI and x3i. So let me create some space over here to solve this further. Now see, the population model that we were given is this: yi equal to beta 1 plus beta 2 x2i plus beta 3 x3i plus ui. This is the population model that we are given, and the sample counterpart is going to be yi equal to b1 plus b2 x2i plus b3 x3i plus ei. If we are estimating this model using the method of OLS, then to find the values of b1, b2 and b3, we are going to minimize summation of ei square with respect to b1, b2 and b3. And how do we do the minimization exercise? Basically, we are going to partially differentiate summation of ei square with respect to b1, and then we are going to put it equal to 0. We are going to partially differentiate summation of ei square with respect to b2, and then we are going to put it equal to 0. And we are going to partially differentiate summation of ei square with respect to b3, and then we are going to put it equal to 0. We will have 3 equations and 3 unknowns, and this is how we figure out the formulas to calculate b1, b2 and b3. Now I'm not going to derive these formulas over here, but I will do some basic steps to evaluate the expression that we have got. So from this equation, I know that ei is equal to yi minus b1 minus b2 x2i minus b3 x3i. We have to minimize summation of ei square. So if this is what ei is equal to, then ei square will be equal to the square of this term, and summation of ei square will be equal to summation of this. So this is what we have to partially differentiate with respect to b1, b2 and b3. If I differentiate this partially with respect to b1, then I will get 2 summation yi minus b1 minus b2 x2i minus b3 x3i. This entire thing will be multiplied with the differentiation of the term that is inside the bracket. So what is the differentiation of the term that is inside the bracket with respect to b1? The differentiation of yi with respect to b1 is going to be 0. The differentiation of minus b1 with respect to b1 is going to be minus 1. The differentiation of minus b2 x2i with respect to b1 is going to be 0. And the differentiation of minus b3 x3i with respect to b1 is going to be 0. Now note that I'm not going to explain you the partial differentiation over here, as I have already covered that in a step-by-step manner in one of my other videos. If you are struggling with the partial differentiation of this particular expression, then do take a look at the description of this video. I have put a link in the description of this video which will take you to the video in which I have explained the partial differentiation in a step-by-step manner. Okay, so I'm not going to explain the partial differentiation over here. I'm assuming that you are okay with this. So if we partially differentiate summation of ei squared with respect to b1, we get this expression, and now we have to put it equal to 0. So this becomes, over here we have minus 1 and this is 2. So this becomes minus 2 summation yi minus b1 minus b2 x2i minus b3 x3i equal to 0. Now I can divide both the sides by minus 2. So if I divide both the sides by minus 2, this minus 2 and minus 2 gets cancelled, and on the right hand side you still have 0 because 0 divided by minus 2 is 0. And now the main thing that you need to note over here is that the term that I have written inside the summation, that is this term, is nothing but ei, because ei is defined as yi minus b1 minus b2 x2i minus b3 x3i, and that's the same term that you have over here. So this expression is giving you summation of ei equal to 0. Okay, so if you differentiate your summation of ei square partially with respect to b1, we get summation of ei equal to 0. Now see, I'm not going to complete this differentiation exercise. The purpose of this question is not to find the formulas for b1, b2 and b3. It's just that when we do this differentiation, we get some information related to the behavior of EI, and we are going to use that information to evaluate this expression over here. Okay, so the first information that we get from the OLS method is that the summation of EI has to be 0. Let's find some more information. So now I'm going to differentiate summation of EI square partially with respect to B2. So if I differentiate summation of EI square partially with respect to B2, I will get 2 summation yi minus b1 minus b2 x2I minus b3 x3I. Then you have to multiply this expression with the differentiation of this term with respect to b2. The differentiation of yi with respect to b2 is 0. The differentiation of b1 with respect to b2 is 0. We are doing partial differentiation. The differentiation of this term with respect to b2 is going to be minus x2I, and the differentiation of last term with respect to b2 is again going to be 0. And now you have to put this equal to 0. So we get 2 over here. We have minus x2i over here. I can write this minus sign with 2. So this expression becomes minus 2 summation yi minus b1 minus b2 x2I minus b3 x3I multiplied with x2I equal to 0. Now once again, what is this over here? This is EI. So from here we get minus 2 summation EI x2I equal to 0, and now I can divide both the sides by minus 2, which will imply that summation of EI x2I is equal to 0. So this is another piece of information that I get. Let's now find the third piece of information. So for the third piece of information, you have to differentiate summation of EI square with respect to B3. And when you do this, you will get that the differentiation is equal to 2 summation yi minus b1 minus b2 x2I minus b3 x3I. And now you have to multiply this with the differentiation of the term that is inside the bracket. The differentiation of yi with respect to b3 is 0. The differentiation of b1 with respect to b3 is 0. The differentiation of this term with respect to b3 is 0. And the differentiation of the last term with respect to b3 is minus x3I. And now you have to put this equal to 0. We have a negative sign over here. I can write this negative sign with 2. So you get minus 2 summation yi minus b1 minus b2 x2I minus b3 x3I multiplied with x3I equal to 0. Now once again, I can divide both the sides by minus 2, and if I do that, I'll be able to get rid of this, and the right hand side will still remain 0. And this is nothing but EI, so this implies that summation of EI x3I is equal to 0, and this is the third piece of information that we have got. So let me summarize whatever we have got till now. So this is what we have got till now. We have got that covariance of EI with y hat is equal to this expression, and there are 3 pieces of information that we have for EI. Now the thing that you have to understand is how are we going to utilize these pieces of information to say something about the covariance between EI and x2i and the covariance between EI and x3i. Let's see. Let's try to evaluate the covariance between EI and x2i. So we can write that the covariance between EI and x2i is equal to summation of EI minus E bar x2i minus x2 bar divided by n minus 1. I hope you know this formula to calculate the sample covariance between two variables. So it is the summation of the first variable minus the mean of that variable multiplied with the second variable minus the mean of that variable, and these two terms are multiplied, and then you have to divide the entire expression by n minus 1. Let's try to evaluate this expression further. We know that summation of EI is equal to 0, and this term that you have over here is mean of residuals. We know that the sum of residuals is equal to 0. That means the mean of residuals is also going to be 0. So this is 0. So we get summation of EI multiplied with x2i minus x2 bar divided by n minus 1. Now let's multiply these two. So I'm going to multiply this with this and this with this. This implies that covariance between EI and x2i is equal to summation of EI multiplied with x2i minus EI multiplied with x2 bar divided by n minus 1. Now I can apply the summation to this and the summation to this. So this implies that we get summation of EI x2i minus summation of EI x2 bar divided by n minus 1. Now see, x2 bar over here is the mean of the variable x2, and the mean of the variable x2 is going to be a constant. Okay, so I'm going to write this expression as summation of ei x2I minus x2 bar summation of ei, because this x2 bar can be written separately, and then we have summation of ei, and this entire thing is divided by n minus 1. Now I know that summation of ei is 0, so the second term becomes x2 bar multiplied with 0, and we also know that summation of ei x2y is 0, that means this term is also 0. So the numerator becomes 0 minus 0, which implies that the covariance between ei and x2y is equal to 0. Okay. Similarly, you can evaluate the covariance between ei and x3i. You will have to do the same steps that I have done over here. It's just that instead of x2i, you will have x3i everywhere. So over here you will have x3i minus x3 bar. Over here you will have x3i minus x3 bar. Over here you will have x3i. This will become x3 bar. This term will become summation of ei x3i, and this will be summation of ei x3 bar. And the final term will be summation of ei x3i minus x3 bar multiplied with summation of ei. And we know that summation of ei is 0 and summation of ei x3i is also equal to 0. So once again you will get that even the covariance between ei and x3i is equal to 0. So now we have shown that this covariance is 0. This covariance is also 0. This implies that the covariance between ei yi hat is equal to 0. And if the covariance between the residuals and the fitted values is equal to 0, this implies that even the correlation between the residuals and the fitted values is going to be 0. And this is what we wanted to show. Okay, so that's it for this video.